Welcome, dear grade 9 students. Hope you are fine. We are going to talk about the chapter called Lines in the Coordinate System. But before starting any new idea, let's make a brief revision for ideas you already know. I have to remind you of ideas that you should recall all over this chapter in order to understand and to apply the new ideas. And the first thing we are going, or the first idea we are going to review is all about the coordinates of a point. So what are the coordinates of a point? So as you see here, if there is a point P written as follows, like an ordered pair, x then y, that means this point P has two values that are real numbers. The first value, which refers to x, is called the abscissa of P, and the second value that refers to y is called the ordinate of P. Both together are called the coordinates of P. Here are a bunch of points that we are going to talk about and to recognize as well. Now this is what we call the x-axis. So again, this is called the x-axis, or as you see here, x prime x. The origin of this system, as you see, is O. And this is an orthonormal system where the axes are perpendicular and the unit on the x-axis is exactly equal to the unit on the y-axis. Of course, there are kinds of coordinate systems, but all what we care about and we are going to deal with is the orthonormal system. So again, this is called the x-axis, and this is called the y-axis, which is the axis of ordinates. So if I'm going to deal with ordinates, I move along the y-axis or parallel to it, and if I'm dealing with abscissas, I move along the x-axis or parallel to it. Here are the coordinates of the points you see here. For example, the coordinates of point A are 1, 2. That means this is representing the abscissa x, and 2 represents the ordinate y. So the first one represents the abscissa, which is the value of moving along the x-axis, and the second one represents the ordinate. So let's see how is A plotted. We have to move 1 in the positive sense, as you know. This is the positive sense along the x-axis, and this is the negative sense along the x-axis. This is upwards is the positive sense along the y-axis, and downwards is the negative sense along the y-axis. So since the abscissa is 1, then I'm going to move from the origin. We start from the origin 1 unit because it is +1 to the right because we have it positive. Then I have to move upwards 2 units because also the ordinate is positive, so I have to move in the positive sense. Similarly for the other points, let's continue about B. B is of coordinates, as you see, -2, 3. Again, we move -2, then we go upwards 3 units. C is -3, -1, then I have to move 3 to the left, as you see here. So 1, 2, 3 to the left, then -1. So as if I'm moving 1 downwards. D is 3 -2. Here is point D, as you see, we have to move 1, 2, 3 and go downwards 2 units, and here is point D. E is for 0. Notice that the y of E is 0. So E is not going to go neither upwards nor downwards, so it will stay along the x-axis. So here we move 1, 2, 3, 4, and here is point E, and finally F is 0, 4. Note that the abscissa of F is 0, then F doesn't have to move right or left. F just moves along the y-axis, and it moves positively because its ordinate is positive, so we go upwards 4 units. And this is a revision for the coordinates of a point and for plotting points as well. Let's continue our revision, and now we are going to know more about the midpoint of a segment. So, if we have 2 points, A of abscissa XA and ordinate YA, and B of abscissa XB and ordinate YB, then the coordinates of the midpoint M of segment AB is given by, the rule is M, remember, M is the midpoint of the segment AB. So, X of M is equal to XA plus XB over 2. And Y of M is equal to YA plus YB over 2. And let's make a training exercise to make things more clear. Given the points A, 2, 1 and B, minus 1, minus 5, I need to calculate the coordinates of M, the midpoint of segment AB. So since M is the midpoint of segment AB, then I have to apply this rule. XM equals XA plus XB over 2. Now what is XA here? It is 2. And what is XB? It is minus 1. So 2 plus minus 1 is directly 2 minus 1. Over 2 is 1 over 2. Now Y of M, applying the rule, is YA plus YB over 2. What is YA? It is 1. And YB is minus 5. Then 1 minus 5, 1 plus minus 5 is gonna be 1 minus 5 over 2, which is minus 4 over 2, which is minus 2. And by this, we find the coordinates of M, the midpoint of the segment AB, and they are half and minus 2. This is for the abscissa, and this is for the ordinate. And here is another example to make the idea of the midpoint more familiar to you. Given the points A, 0, minus 5, C, 1 and minus 2, I have to calculate the coordinates of the point B. But what is B? B is the symmetric of C with respect to A. Then we are dealing with the principle of symmetry with respect to a point. Let's recall, symmetric of B is symmetric of C with respect to A. Then A has to be in the middle as a midpoint. So here is point A, and as if I have C here and B here. So B is symmetric of C with respect to A. Then A is the midpoint of BC, as you see here. And now we apply the rule concerning the midpoint. The rule says XA equals XB plus XC over 2, since again A is the midpoint of BC. Now I have XA, so I just evaluate. XA is 0, so I evaluate 0, equals XB is the needed value because I need to find point B, and plus XC, I have XC, which is minus 2. Sorry, XC is plus 1. So I have to evaluate X of C over 2. Now I put 0 over 1 and I cross multiply, then I will get that XB plus 1 times 1, 0 times 2 is 0. Then XB plus 1 equals to 0. So taking 1 to the other side, XB is equal to minus 1. Now similarly for Y, Since A is the midpoint of BC, then YA equals to YB plus YC over 2. So again, I have YA, so I evaluate, equals YB is the required value, plus YC, which is minus 2, so plus minus 2 is just minus 2, and over 2. Again, I put minus 5 over 1. I cross multiply to get YB minus 2 equals minus 10. Now taking 2 to the other side, I get that YB equals minus 8. And then B has the coordinates of minus 1 for the abscissa and minus 8 for the ordinate. Now turn the engines on and think of this exercise. I have 3 points, M of coordinates 2, 3, N of coordinates 1, minus 3, and E of coordinates 0, 5. Find the coordinates of point K, which is the midpoint of MN. So just applying the rule to find the coordinates of the midpoint of MN. Now in part B, the trick is hidden. Deduce the coordinates of I. What is I? The fourth vertex of the palm mine. So if we make a baby sketch for the palm mine, it's like M, I, N, E. In part A, I was asked to find the coordinates of K, the midpoint of MN. How does that part help me to deduce the coordinates of I? Think of that, and I'm sure you are going to get the answer correctly. Just turn your engines on and think of it carefully.